the fourth example is to take the curves perpendicular to the parabolas. This is another geometry problem. And by specifying that the curves are perpendicular to these parabolas, I'm telling you what their slope is. So let's think about that. What's the new equation? The new diffie-q is the following. It's that the slope is equal to the negative reciprocal of the slope of the tangent line, of tangent to the parabola. Okay, so that's the equation. That's actually fairly easy to write down because it's minus 1 divided by 2y divided by x. Right? That's the slope of the parabola. Right? 2y divided by x. So let's rewrite that now. This is, the x goes in the numerator, so it's minus x over 2y. And now I want to solve this one. Well, again, there's only one technique, which is we're going to separate variables. And we separate the differentials here, so we get 2y dy equals minus x dx. That's just looking at the equation that I have, which is right over here. dy dx is equal to minus x over 2y, and cross-multiplying to get this. And now I can take the antiderivative. This is y squared. And the antiderivative over here is minus x squared over 2 plus a constant. And so the solutions are x squared over 2 plus y squared is equal to some c, some constant c. Now, this time, things don't work the same, and you can't expect them always to work the same. I claimed that this must be true, but unfortunately, I cannot insist that every c will work. As you can see here, only the positive number c can work here. So the picture is that something slightly different happened here, and you have to live with this, is that sometimes not all the constants will work because there's more to the problem than just the antidifferentiation. And here there are fewer answers rather than more answers. In the other case, we had to add in some answers. Here we have to take them away. Some of them don't make any sense. And the only ones we can get are the ones which are of this form, where this is, say, some radius squared. Well, maybe I shouldn't call it a radius. I'll just call it a parameter, a squared. And these are, of course, ellipses. And you can see that the ellipses, the length here is what it's the square root of 2a, and the semi-axis, vertical semi-axis, is a. So this is the kind of ellipse that we've got, and if I draw it on the previous diagram, I think it's somewhat suggestive here. Their ellipses are kind of eggs. They're a little bit longer than they are high, and they go like this. And if I drew them pretty much right, they should be making right angles at all these places. Okay, last little bit here. Again, you've got to be very careful with these solutions. And so there's a warning here too.